I think this talk dovetails really nicely with the folks from Toast right before this, where they were discussing sort of how they did some infrastructure plumbing to harness Pulsar in a few contexts related to release engineering and blue-green. And then at the end of their boxes and lines, there was this little box about like, okay, we've got this consumer library everybody uses, and then they run their code in there. And this is my discussion of Klaviyo's in there. Namely, we built an asynchronous application framework that fronts Pulsar and used that to deliver its messaging capabilities to our org. I'm here all the way from Boston, and I'm incredibly grateful to Addison and the Stream Native folks, but specifically to Addison because he pronounced the company's name right. It is Klaviyo, not Klaviyo. Sorry, happens every time. Talk about a few things here, sort of a similar structure to the Toast folks talk. Going to give an overview of some of the technical challenges Klaviyo faced, talk about how we solved those, and that's honestly going to have pretty minimal emphasis on Pulsar, both because I want to give you all a palate cleanser after a long day of deep dives, and because I want to emphasize delivery to an engineering org of messaging capabilities rather than the capabilities of the broker. Like preaching about how awesome Pulsar is would be great, but that wouldn't even be preaching to the choir. That would be sort of preaching to the preacher, right? Instead, we're going to talk about that delivery. We're going to talk about lessons learned from doing that I think will be applicable to a lot of folks here, even if your stacks don't look anything like Klaviyo's. Like we use a lot of Python, you probably don't. But if you apply some of the patterns that we found to be useful during the development of this framework, we think it's probably beneficial stuff. And before Q&A, I'll wrap up with some future plans and tease some open source offerings we might contribute back to the community and just generally do all that vaporware stuff that you're supposed to do at the end of talks that have code in them. So, a little bit about Klaviyo first. We're a marketing platform and CDP out in Boston. We sit at this sort of middle layer between our customers that are big online stores and their customers, the people that they want to communicate with. And architecturally, I like to say Klaviyo is a lot like an iceberg, where a lot of other companies' major business logic and most of what they do lives primarily in a web application with some asynchrony around for serving data lakes or data lake houses or doing a little bit of offline processing. The vast majority of Klaviyo's compute is in-queue consumers or stream consumers. The minimal amount of our code is actually in the web tier, and we've got a great web application. We like it very much, but I think it's like a 9-to-1 compute gear at Klaviyo is stuff that runs in-queue consumers versus stuff that runs on the web edge. And while we do have some large homogeneous bulk data shippers in those queue consumers, sort of feeding data lakes or warehouses, et cetera, the vast majority of the processing we do is message at a time business events. That is to say, things that have really high durability needs. Maybe they're flying to us from an on-site event on a web page or something. They're not somewhere we could generate a replay from easily, so they need to be persisted with extremely stringent guarantees. They have really unpredictable throughput because they might be driven by flash sales or something like that. And those events trigger tons and tons of ad hoc processing. That changes often. Like user code reacts to messages in an at least once way, but that's more or less where we get off the invariant boat. And after that, you can talk to whatever data stores you want, trigger any downstream side effects you want. And we have a lot of code in there. We have multiple thousands of queues, each driving a distinct workload. And when I say distinct, I mean very distinct. There's no higher governing contract or Flink-style job manager that things run within. It's you write a callback that reacts to a message on a stream. That iceberg is built, for the most part, on Python, RabbitMQ, and Celery, at least right now. And I'm telling you the story about how we're moving to Pulsar. In very broad strokes, our existing infrastructure looks like this, but with a lot more colored boxes. The teams in the colored boxes own their whole stacks, down to the data stores, and they do varied processing in reaction to messages on those data stores. They get most of their work requests from RabbitMQ or another queue service, and some of those queues are fed by producers on the web edge, the sort of upper left. Wow, this is inverted, wild. The upper left edge of that graph, the producers are fed from the web edge sometimes. Sometimes they're fed from other teams' domains or other queue worker consumers that double as producers. It gets very complex. For example, a queue worker sending SMSs might publish a message to the queue worker's processing event saying SMS was sent to this person, and then the event processing queue workers trigger segmentation or workflow activation based on that, or storage in a data warehouse, or an HTTP post to something downstream. You get the idea. We've got thousands and thousands of these. And teams own all of their infrastructure, including their RabbitMQ. Most of this runs in a monorepo. We're moving in a service-oriented direction right now. But infrastructure-wise, the ownership is fully distributed. Each team owns their Rabbit. They own the data stores that their Rabbit consumers talk to. And the write publish queue amplification is pretty big, given that you're getting fed events from other queue consumers at Klaviyo. So owning a RabbitMQ is no small task. There's a lot of late night wake-ups. There's a lot of rough expertise garnering that individual product teams have to go through. That brings a lot of expertise to the org, but it's not without its challenges. If your Rabbit has an issue, it's on you. You don't really get to call the Ghostbusters here. So we got a really long way with that stack. And that is still the stack I would recommend if a company the size of Klaviyo in 20-something teen came to me and said, I want to build an iceberg. I want to build a system that is primarily asynchronous job processing. And we've got, with those technologies, frankly, farther than I've heard any other place get with RabbitMQ and Celery, at least along certain axes of scale. So it was the right choice. But we outgrew it. And problems began to emerge when it came to scaling the queues themselves, when it came to scaling the broker technology, when it came to scaling the teams, and when it came to sort of bringing new architectural best practices into our sort of scrappy startup code base and trying to evolve that into something a little more mature, a little more enterprise-like. Those problems came along all the axes you'd expect. More teams, more frequent resharding and geometry changes of all of those downstream data stores and those rabbits, more movement of the code base and development styles towards service-oriented architecture, and just generally the kind of things you do at 10,000 RPS and tens of engineers don't work at hundreds of thousands or millions of RPS and hundreds of engineers. So had to make a change. To drill into those problems a little bit more, started on the SRE side. Rabbit doesn't hold up great with very bursty or very high publish volume, especially when you're publishing in full disk durability mode to survive data store loss. Its behavior when subjected to too high a rate is pretty poor in that it becomes unstable rather than backing off intelligently or applying back pressure in a predictable way. Running really deep queues, so your prototypical, I want to pump 10 million messages into something and process them over a week. Running really deep queues in a Rabbit that's multi-tenant and is doing other high priority things can hit some pretty surprising performance cliffs. And Rabbit didn't until recently have a good redundancy story in that when you added replicas to your data stores to try to allow Rabbit to weather node failures better, you actually lost reliability in some fairly fundamental ways, which is unusual and unfortunate in most of my experience with distributed databases. We also hit some scalability issues. Even if things were reliable, which they weren't most of the time, scaling Rabbit is tough. We accomplished it by sharding our rabbits and sort of torturing our application code to reflect that sharding geometry at many, many layers that really shouldn't have been aware of the sharding geometry of our message stores, and that wasn't pleasant for anybody. And like any statically sharded scheme, geometry changes when you outgrow a given shard geometry are not pleasant. Process-wise, every team had to deal with that. Every year when there was a big shopping holiday or volume push or unexpected change, every team fully owned their brokers. And they were spending a lot of cycles keeping their rabbits and their rabbit maintaining expertise up and up to date, handling outages, scaling, resharding, et cetera. And they all got pretty good at it. On the bright side, they all got great at it. On the less bright side, they all got pretty good at it. That is, dozens of engineering teams spending cycles doing roughly the same variety of keep the lights on work, scaling this troublesome queue system that each one of them owns their own little slice of in the monolith. Architecturally, this is really sort of the jumping off point for this talk, which is that there were tons of important enterprise patterns that were off the table for Klaviyo due to our choice of Celery. Raise your hand if you've used Celery at all. I have no Celery users in here. I have one Celery user. Two, got like a handful of Celery users. Well, congratulations to the rest of you. It is an interesting and challenging tool to try to scale. It's a very easy tool to start using. Sometimes I make a methamphetamine joke there. I'll skip it today. Anyway, important architectural patterns that were off the table for Klaviyo. One, consuming data in ordered or semi-ordered ways. Not really an option with Rabbit or with Celery. Two, receiving or buffering more than one message at a time in a consumer. Not really an option. So if you want to do something that's faster in batches, like, oh, I don't know, something esoteric like a relational database insert, tough. PubSub, that is multiple consumers, is possible with Rabbit and Celery, but not easy. You have to become a little bit of an expert. Replay and queue introspection at rest aren't really possible at all. This is the sort of standard use case for a log versus a queue. Your data's gone once you pop it. And the big one, Celery and queued RPC in general are super hostile towards moving away from a monolithic code base to a service-oriented architecture. For context there, let's look at what some of our prior, still the majority of Klaviyo, but we're burning it down, prior producer and consumer code looked like. On the producer side, you import a function. Your function has a magic decorator, annotation for the Java crew, applied to it wherever it's declared that says you can call this asynchronously. When you call it asynchronously, you issue that apply async call on the function object. It serializes wherever the function's code location is and the args and kwargs you passed to it and sticks that in a JSON blob, publishes that JSON blob to a queue that's stored in a big mapping of function named a queue somewhere. And the far side pulls it out, runtime imports it, or class loads it for the people that didn't raise their hand that they've used Celery. And you're off to the races. This is very, very easy, very simple, and is absolutely the right tool for small companies getting started with queued RPC. But a few problems arise pretty quickly. Again, like This is literally just a function. It's not equivalent to a function. It is just a function. You can see it, you can import it, you can call it synchronously. You just happen to be able to publish it as well. It's a go-to definition away. It's very easy to see what it does. But problems. One, what if a publisher supplies bad arguments to the function, like an invalid signature? You call it asynchronously via that second form with an argument that it can't accept on the far side. Two, what if the arguments you supply to that function become bad? Like the consumer code gets updated and your publisher code doesn't because you're in the middle of a blue-green swap or something, and suddenly the function on the far side is receiving arguments it doesn't expect it to. What if the function isn't clear on what arguments or types it takes? This is a Python problem, maybe, and probably not a problem shared by many other ecosystems, but that can become a little bit troublesome, especially if I want to know what I want to serialize and publish to that queue. What if some of the function's arguments aren't serializable? It's really easy for complex arguments with things that blow up when you try to serialize them to make it into call args. And the more similar you make your queue consumer actions to regular functions, the easier it is for people to forget they're not. What if the function you want to call isn't defined in your code base? This is the big one. What if that function's defined somewhere else? Ice cold take, like sometimes people want to run multiple code bases, multiple services. What do you do here? Answer, not much. Celery gives you some escape hatches where you can call things or publish by function name, but that trades away the little safety you had with regards to predictability and protocol shape and schema of queue messages that you had to begin with. This is pretty rough. And these are all things we could have lived with, right? Like we scaled on these for a long time. We went multi-code base, multi-service with these. We scaled our rabbits. We did this effectively. We got pretty good at it. And we could have kept doing that. We could have hit the square peg of RabbitMQ and Celery really, really hard and doubled down on our scaling that out or hiding the pain points for years and years more. But the missing mechanical sympathy of that system with how we wanted to write our code, those new capabilities we wanted to unlock, would have kept biting us. Similarly, we could have solved this by just going huge. Complete re-architecture, maybe a language switch with something like Flink, where you architect all of your code to reflect stateful data flows and structured side effects. And we do use systems like that in a few places where they make sense. Those are very powerful, but you really have to redo most of your code. It's not just changing how you ship data, it's changing the entire paradigm you work in. And it gives away the extreme agility and freedom of that ad hoc per-message processing that our developers are used to. Instead, we ended up in this niche where there weren't really great solutions, so we opted to solve them with our own. It had the following parts: cold takes to hot takes, going down the list here. One, we moved ownership of message brokers centrally to a new team, so we own and provide messaging services. Every team doesn't have to own and run their own anymore. We adopted Pulsar. We ran a few large clusters rather than one per team, and we did that with help from Stream Native. And then we got to the hard parts, which is we now had this messaging capability that unlocked all these things we hadn't been able to do previously. We theoretically had a lot more reliability waiting in the wings as well. But we had to figure out how to deliver that new capacity and those new capabilities to an engineering organization without just replacing, hi, you have to be, welcome to Klaviyo, you have to be an expert at RabbitMQ. You've got to be a senior level RabbitMQ DBA. With the statement of, hi, welcome to Klaviyo, you have to be an expert at Pulsar. To do that, we built this new framework we call Chariot that fronts our brokers and associated services, and it's analogous to Celery. It's not equivalent. We sort of got rid of the parts we didn't like and enhanced the parts we did. We deliver that as a library right now, and its goal is to, over the long term, be the only way code inside Klaviyo communicates asynchronously. From any service, to any service, any volume, anywhere. We're in the process of converting teams onto that framework right now. Say the majority of teams have at least one use case, some have several, and the long-term plan is to move everything off of our legacy messaging infrastructure and onto that. To give you some examples of what we learned there, there's a couple slides of code examples after this. And this is not an interactive demo, it's not a full code tour, there's many, many more features and capabilities that I'm not covering. These are snippets that demonstrate patterns that we've found to add the most value and patterns that I could see you all, whether you run Python or RabbitMQ or Celery or Java and Pulsar, adopting for great good. This is about the patterns, it's not about the code, so don't get scared off by the Python. I get scared off by my own Python often. That's not a diss, I promise. The code's in Python, but the ideas are not language specific, or even really broker specific. I'll go through them pretty quick, and then at the end, we'll talk about some of the standard lessons learned, the pain points encountered, et cetera. And my hope is that most of these will be pretty cold takes. That maybe one or two of them will give you ideas about things to sort of go back to your respective businesses and improve the way you deliver messaging functionality to your engineering org, but the vast majority of them are already being done in one form or another. If they're not cold takes, like I've made a wrong term somewhere. So first thing we made, this one barely rates a slide, but I put it up here mostly because it might be one of the first things we open source sort of piecemeal. The first thing we made is an ORM for the Pulsar management API in Python. I wish I hadn't been able to write, or I hadn't had to write this, rather. I wish I'd been able to auto-generate a management client from Swagger and OpenAPI and go from there, but Interacting with the Pulsar Management API is a significant struggle. It's a major pain point for us. And we wanted to give our users pretty direct controls over a lot of the fine-grained advanced functionality of the broker. So doing it with less than full-featured tools, like a poorly auto-generated OpenAPI client or a bunch of things shelling out to Pulsar admin, didn't work well together. Maybe hindsight will show that this is over-engineered. It's totally possible. But the most important thing about this is that it enabled us to build this. This is the sort of beating heart of Chariot. This is a topic schema definition. Schema means two things in Chariot. Schema as in defining a stream of data and its behavior in terms of rate limiting and capacity, and also schema in the more traditional sense, defining the shape of payloads that it carries. These are checked into a single repository and versioned. A migrator runs against them and diffs the existing broker state against them as a desired outcome and makes appropriate changes if you tell it to, just like Hibernate ORM or the Django ORM or something like that. Teams check them in, they submit them to my team in the form of capacity estimates. They say, okay, we would like a topic with messages about yay big, producers and consumers counted like yay with a rate limit of so-and-so and act and unact thresholds of X, Y, and Z. Can you sustain that? And we either say, yes, PR approved, ship it, we'll migrate, or no, please wait, we're gonna online some more capacity, and once we're done doing that, you can have your topic. And you put the protobuf down at the bottom there, that's the payload that the topic carries, just like any other Pulsar client. And an important thing to note here is that there's very little Pulsar-related info on the screen right now, which is exactly what we want. It's not that the system needs to be back-end agnostic, it's not, it won't be. But our users want semantics expressed in terms of their application's goals rather than the broker technology's names for those goals. That also lets us polyfill in bits of functionality that aren't, for example, supported by the Python Pulsar client, or that we may want to implement client-side or with some other data store for some reason. Think about rate limiting applied per key rather than per topic. Remember, this is where we're coming from. So this is a jump back to a previous slide. We're about to show the new version of producers and consumers here. We're coming from this very one message at a time, very you are in the same code base, you're just doing RPCs land. And we're going to here. Again, very little Python specific on this screen. It's a producer and consumer API. Producing seems very straightforward, but there's an interesting property there, which is you can't produce to a topic unless you can import that topic. You can't import that topic unless it's available for your code to import, and you can't import it unless we've approved a PR that says, okay, your topic will be migrated into existence. So you have this very nice control on what exists where and what shape it has. Similarly, in the consumers, you've got a batch-oriented consumer callback. That's that on-message batch function at the very bottom there. The guts of this are quite complicated and esoteric, where you've got a consumer and a parent process farming things out via gRPC to those things on the bottom there, those executors. But the executors end up with a batch of messages. They can ACK them out of order or NACK them out of order or not. Even if your batch size is 1, you can still think about consuming things in configurably sized batches. And similarly, you can't run them or interact with them unless you are able to pull in the topic you're consuming from the schema registry. So you have this, even in as interpreted and dynamic a landscape as Python, you have this fairly nice, almost compile time-ish guarantee of you import it, therefore it exists. You can't, therefore it doesn't, which beats the heck out of sort of floaty queues and floaty schemas around a multi-code-based system with no central authority of schematic state. Also, sort of as an inevitable side effect of this design, the coldest take of the century, consume is no longer an RPC call. You can treat consumed data as data and react to it as you see fit. Run multiple consumers if you want and react to it in different ways if you'd like. There's one interesting thing I want to note here before I leave, which is that on-shutdown requested method. This is the only piece of concurrency we provide user code. That method runs whenever a shutdown is requested of the user runtime for any reason. The rest of the time, it's just processing on-message batch over and over and over in sort of shared nothing parallel one. And we parallelize at the process level. That one's maybe not as applicable to the Java folks. But that on-shutdown requested method runs in reaction to every shutdown required event. A clean shutdown, a timeout, a signal received, an unhandled error, et cetera. Moving concurrency out of most of the equation and only supplying this like concurrent, maybe flip a shutting down bit ability for when something goes wrong or the lights are about to go out, enabled our users to think about a lot less in terms of race conditions and threading and shared mutable state and all those tangling problems. There's a few more bits of advanced functionality you've got. There's an API for doing retries. Some of those are NAC-based, and some of those are republish a duplicate to the back of the queue base if you can handle the reordering. Some of our consumers use multiple parallel instances of executors and sort of intelligently route batches of messages to them over time. And we've got some advanced knobs you can tune there to control which parallel executor process a consumer parent process decides to give messages to. And you can say, okay, I want messages with a given key to only ever be in one process in my whole distributed system at once, ever. and use a fairly exclusive routing mode. You can say, I want affinity. I want you to sort of reuse processes that have seen this key before. Maybe they've got some warm in-memory caches for me. Or you can do the classic sort of round robin, whatever you want there. And we let people sort of tune that and massage it around, and it's all behind a consumer that obeys Pulsar's usual semantics about where it routes what in what produce mode. Sorry, in what topic mode, what subscription type. Those are just some of the highlights. Again, there's a ton more to do with that framework. The two most significant are the middle slides with the declarative topic and message schemas and sort of importing those schemas to publish and consume, and the data-oriented, batch-oriented consumer APIs. So now we're sort of back here. How did those capabilities and the other stuff we built and the process changes we made as a company help us solve the problems I listed out to begin with? On the reliability angle, this one's pretty simple. You can't opt out of guardrails anymore. To submit a topic for use in production is to submit the rate limits it'll be subjected to, and to submit them to us is for us to plug it into our capacity estimates and tell you if they're okay or not. We don't really let you default those things because we really want people to get used to being explicit up front. Additionally, Pulsar is redundant, unlike our sort of 3 spoffs in a trench coat approach to RabbitMQ, so that's a big benefit in terms of peace of mind overnight. The Toast folks covered that. Scalability-wise, our team can scale Pulsar's infrastructure the normal way. I don't have to go into that. You can scale out various axes of your cluster. You can repartition. Users can propose schema migrations that request additional capacity along some axis, maybe size, backlog, rate limit, you name it. And we will approve or reject that after plugging its updated numbers into our capacity estimates. This is a fairly straightforward process. Additionally, we're able to sort of get scalability support from Stream Native in the Pulsar community, and we appreciate that a lot. Ownership-wise, by releasing just the framework and telling our customers, our internal teams right now, that they just own their producer and consumer instances. They don't own the data stores it talks to. They have a much clearer separation. And they get to express those contracts as PRs against the schema registry for us, and then we hold up our end of that separation, which is providing the behavior in the contract they requested. This beats the heck out of everybody owns their own little slice of everything. Architecturally, a lot of new things are on the table now. Consumer logic's expressed entirely in terms of batches of data rather than single one-at-a-time RPCs. That unlocks all these listed capabilities here, which in turn unlock all sorts of powerful architectures like event sourcing and CDC and stream to table and all those things we've heard people talk about today. And SOA is now trivially possible because multiple code bases can import that version schema registry and consume things that have a predictable shape as they come to them. They can depend on those registry artifacts, run producers and consumers on the topics in those artifacts in an at least predictable way. We have not solved online schema migration, right? Like you can depend on a version of the registry that has a topic protobuf that is different from the one being put into the topic right then, but the answer to what the hell am I getting is then, well, whatever protobuf's documented back compatibility between the produce version, which is present in our telemetry and you can figure it out, and the consume version is, it's not, whatever they felt like putting in there today, which is an improvement. Now I want to talk about some things that went less than well. It did solve those problems and effectively, and we're happy that it did, but there were a few roadblocks on the way. The first one is it's a library. We opted to distribute it internally as a library versus, say, a microservice, and those are just harder to maintain. You got weird loads of target environments you have to support. You got to support multiple versions in production at the same time. And we're already sort of spoiled in that it didn't initially need to support any platforms besides Python yet. A lot of the time we'd sort of find ourselves at an unfortunate intersection of advanced broker features, being the only user of a particular overlap of, for example, key shared consumers plus deduplication plus frequent consumer disconnects and reconnects, or replicated subscriptions plus Python clients plus compaction plus consumers that disconnect all the time. And these surfaced some Pulsar bugs. Some good, some bad. We're immensely thankful to the community and the folks at Stream Native for always giving us prompt feedback, prompt mitigations, prompt fixes. That was great. The runtime was a challenge to write. This is all hidden from our users, but as many people know, Python's concurrency story is primarily multi-process thanks to this interpreter lock. Working around that was a challenge. Because of memory and consumer cardinality, we needed to run a consumer in that parent process I talked about, supervising multiple parallel actual user code executors. And providing that isolation made sense. It kept our user code from doing naughty things, but there are a lot of dragons here. Pulsar client's already heavily threaded. Our Python code is heavily async await oriented. You're not generally supposed to combine threads and forks unless you re-exec after the fork, which we don't do because we want to share memory, nor are you supposed to combine forks and async await event loops. I could give a whole separate talk on this if you're curious. Hit me after and don't say I didn't tell you so. But we managed, we muddled through that, but it was very much sort of programming on hard mode. We successfully hid it from our users, but it was a challenge. Last big one was expectation management. They say some huge percent of big internal software project rewrites like this fail. We've all seen it. It almost feels worse to be on the other side of that and have a clamoring batch of users constantly asking when will it be ready, when will it have a higher SLA, when will it support feature XYZ, and have to tell them not yet. Like it was quite successful, but that brings its own variety of challenges. I've already talked about a couple of the specific Pulsar technical challenges, the one around management API quality that we got around with an ORM. I'm eager to see what happens in terms of like a V3 API or subsequent reworks of that functionality there, because that was a challenge. It's not a super high quality control plane at the moment. And another challenge we've worked with a lot is the gap ledger. Because our message streams are so heterogeneous and our things process at such different rates, and because we provide that batch-oriented API to our consumers, where they can like act things out of order in the middle of it. This is in contrast to Ignacio's talk, where that HTTP post provides one batch to his consumer entities, and they provide a single set of responses about what they want with the messages in that batch back. We let people sort of do it bit by bit by bit, but this causes a wide segment in the middle of Pulsar topics between the range of contiguously acknowledged and contiguously unacknowledged messages, where things are sort of sparsely unact, allocated to consumers or not, et cetera, and that's difficult to work around. It causes some challenges to arise. Again, feel free to reach out if you're curious. But for all those challenges, and those are sort of inevitable challenges, we adopted a new and growing technology and we decided to use it to the absolute hilt, maximize mechanical sympathy everywhere we could. That was bound to hit some trouble, and we hit the expected trouble and we got through it, and we're happy we did. In return, we got a lot. If you are someone who is empowered, not that you should, but if you are empowered in your organization to implement a change in process or technology at this scale, raise your hand. Like, are you the decision makers? Raise your hand, Illuminati. Raise your hand, smoke-filled room, behind closed doors, changing the way the world works, folks. Some hands go up. Please don't, unless you get support from above. The absolute best thing about this project, from a process perspective, is that we went to our CTO and said, hey, we want to stop working on problems that are going to bite us this year. You've got a little bit of engineering capacity for this month. We want to allocate some senior engineers to something that is a problem for the organization growing over the next few years, but it's not something that's going to bite us on Black Friday this year. Furthermore, we want you to promise that as we implement this project and try it out and sort of thread these single user behavior studies through this existing complex messaging environment, we want you to promise us that you will not put a seasonality deadline on us, that we can really get high affinity for what the organization needs to grow without getting distracted by what we need to get this month's outages behind us. And without that, we could have had 3 times the headcount or talent or whatever, and it wouldn't have worked. The steel thread methodology, taken formally or informally, was also pretty critical here. We were able to go and get a single use case of an internal user that we knew really well, get a product developer on board with being our sort of guinea pig, maybe one with SRE aptitude if you're going to do something similar at your company, and follow their needs messaging-wise to craft these APIs, rather than doing the classic SRE mistake of building a solution to a problem nobody has. We also had, from a certain perspective, this entire talk could be seen as like not invented here syndrome writ large, right? Maybe we wrote too much in-house. I would contend that sometimes people err too far in the direction of avoiding those in-house roll your own situations. That's not entirely wrong, but I think people miss things here. If you have tons of organizational experience mitigating issues in a given area, like scaling RabbitMQ or dealing with asynchronous queue consumers in massive bulk, you are often already enough of an SME to craft an actual solution to the problem, rather than just keep mitigating. Like, that firefighting has built the expertise in you. You were wearing the ruby slippers all along, Dorothy. On the one hand, sure, innovation tokens are very expensive, but on the other, entire organizations can and do have imposter syndromes, and sometimes you are the right ones to sort of step into a missing framework or tools niche and provide a solution there, ideally for the community, but at least for your company. Technology-wise, there are a few other things that worked well. Most of them I've covered already. That declarative schema approach to both the entire data flow, the presence of the topic, as well as the payloads on the topic was really useful. Versioning that registry as code rather than as a single point of failure network service a la the Confluent schema registry was great because it tied our release engineering to our broker data flows. Managed Pulsar, thanks to the Stream Native folks, allowed us to learn those tricks with less pain. And isolating user code from consumer code via that sub-process trickery did improve reliability a lot. Lastly, a few teasers for what will be coming up next. Inside Klaviyo, we got to get this thing adopted before we think about releasing anything back to the community, et cetera. So we're going to keep chugging along the internal adoption curve of getting all of our use cases off of those thousands and thousands of workloads and queues on RabbitMQ and onto our new system. We got to scale to meet the annual shopping needs. Until the system has been through a Black Friday, if you work for a MarTech company, you know how significant Black Friday is. Until the system's been through a Black Friday, a lot of people won't trust it, and they should not. After that, we're going to start work on a publish gateway for providing some connection pooling, frankly, for just running the Java client instead of the Python C++ client, and doing some circuit breaking and some interesting middleware type stuff there. And then over the long term, we've got some really interesting grand plans, or at least I do. This one's not CTO approved, right? Got some online schema changes we could do to payloads on a topic using an A/B swap approach. We could associate state with keys in a sort of ad hoc pattern that doesn't require you to fully buy into a key to state mapping approach like Flink. Support complex workflows using something off the shelf and then supplying our own backend for it, and eventually make our work available to the community. When that happens, and I do mean when, it's likely going to start in pieces, supplying utilities, techniques, individual subcomponents of this process as open source components first, and eventually moving towards providing the entire framework into this sort of missing niche between ad hoc messaging via Celery and really large structured data processing. And that's really all I got. Grab me with questions afterwards. I think I've already blown over my time by a couple minutes. Sorry, Addison. And I'm hoping that serves as a bit of a palate cleanser at the end of the day, thinking more about delivering process improvements and tools to an organization rather than diving deep on the broker, which many other people have done really well here. Because if I don't say it, my CTO will remotely detonate the bomb he installed in my head on the day I hired. Klaviyo is hiring. If you are interested in working on problems like this at scale, please go to klaviyo.com/careers. Hit me up by email if you are at all curious, or meet me after the talk. Happy to chat. Cheers.